All of our teachers. All right, how about questions about six? Six. Madison said six.
Hold on. I have one. 11.
I'll do 11 after this one. All right. Y'all are all keyed up today. Charlie, are you disrupting the class? All right, 4x minus 3 on the outside. Inside, 4x cubed minus 3x squared plus 20x. I definitely don't want to be accused of just talking the whole time and not teaching, so I'm going to teach. All right, what do you multiply this by to get this? 1 what? 1x squared, it goes in the top here, and you multiply around. 4x cubed. Charlie, what do you get when you multiply by the second one? Tell me what I do now. Now what?
And then you gotta bring the 20x down.
Oh boy.
Now what?
And then you gotta put one of those two things right there. I forget what it's called. You gotta move something there.
Keep going.
Why would you move the 20 down?
Because you have to. Just trust Wyatt.
Move the 20 down.
We are going to move the 20 down since there's 2 terms here and I need 2 terms here. But what am I going to do now?
Then you subtract 4x from 20x.
Subtract?
Whatever.
One more. Divide 20 by 4. So what do you have to multiply 4 by to get 20?
It's
By 5. Now what?
Now you gotta take the 5 and bring it down to 20.
What?
Take the 5 and multiply it by -3.
No!
-15 or -20 minus -15.
No! Wait.
Yeah.
Right.
So,
20x minus 15.
whatever, that's close enough.
What do you get?
You would get
What does that represent? How do you interpret the remainder? Over what? He's got it. He's got it. Good job. That was a little painful. That's okay.
What is 4x minus 3?
Quotient, right? No, quotient's the answer. There's divisor, dividend, and quotient. I can't remember which one's which. The divisor? I think so too. All right, what else in your homework? 11. Did you put a placeholder? Oh, you didn't need one. You need 3? Okay, I already flipped over. I'll go back to 3. Divided by x squared minus x minus 2. Sometimes the ones that are the longest don't take that long. X squared minus x minus 2. Where's it going? Almost what? I think it's rough. All right. I'll pull it up and see. What was the last homework? Long division or polynomial division. This is polynomial division. That is polynomial division, though. Pretty sure it is. Or what do you multiply x squared by to get 10x cubed? 10x x, right? It goes up top. Multiply all the way around. You get 10x cubed. Then what, Charlie? That's what I was asking you. You take the number up top and you multiply by everything that's on the outside. Yep. Negative x squared minus negative 10x squared. Uh-huh. Negative 9x. Now what? What do you multiply that by to get that? X squared times what gives you 9x squared?
X squared to 9x squared.
Multiply it around, right? It goes to everything. So 9x squared minus 9x minus 18. What's everything cancels out? The first two, you're right.
Oh boy.
Y'all give him a hand. He did much better that time. He did much better. If he would pay attention, imagine how well he'd do. You did it last year in Algebra 2. Slade, which one did you say? 6, 3? 6x cubed plus 25x squared minus 29x minus 20 divided by 2. Actually, it doesn't say to find the zeros. It just says to use division to completely factor. So first thing I'm going to do is divide. Oh, dang it. Okay, sorry. Sorry. What do I need up top first? 3x squared. Multiply it around 6x cubed plus 3x squared and subtract. 22x squared. Now what? What goes up top? 11x. Multiplied around 22x squared plus 11x. What do you get? Now what? Minus 20. Multiplied around negative 40. Oh, nice. As it should, because if it factors, I should get a remainder of 0, and that's kind of what we're talking about today, too. So, to factor this completely, I know that 2x plus 1 times what would give me this? 3x squared plus 11x minus 20. Yes? Now I can split this one up. What multiplies to negative 60x squared but adds to 11x? Look at you. 15x, negative 4x. 2x plus 1, 3x squared minus 4x plus 15x minus 20. Is anybody struggling with this part? Because I'm running through it kind of fast. That's what I divided by. And then this is what I got when I divided. What? Yes. Say again, Wyatt. Multiplies to negative 60, that's these two multiplied together, adds to what's in the middle. Because I needed to factor it, and it had a leading coefficient. just finding these two terms so then I could write them in here. So what are the zeros? -1/2, -5, and 4/3. What else? Anything? That's, yeah. What happens when you divide by a factor? You get a what, Charlie? Say that again. So if you divide by a factor, you get a remainder. Give me a factor of 6. Okay. What happens when you divide 6 by 2? Where's your remainder? I thought you said when you divide by a factor, you get a remainder. You get another factor and it's no remainder. Those are the two theorems here. That's the basis of what this is made on. When you divide by a factor, you get another factor. That's the factor theorem. Huh? I don't know. I should probably not put these little, because there's a little corollary part to it.
Oh my God. Oh my God.
What? This is kind of wordy, and we skimmed over it in Algebra 2, and we're really going to dig into it in pre-cal now. So, when you divide by something, okay, when I divide by one of those factors that I can use synthetic division for. So I'm talking about x plus a number, x minus a number. I put x minus k here. So let's say, for instance, let me use one that's going to work. Bless you. Give me one that did not have a remainder from your homework. Is it? Which one? Give me a number that didn't have a remainder. Number 3, one that could be done synthetically. Which one? 5, 4. Oh, here's y'all's lunch. Okay. All right, you said it did not have a remainder. So let's see what happens. Let's divide it synthetically and watch. This is number 5. You're welcome. You're welcome. Oh, I thought you were saying thank you to me. Oh. Okay. Here's what I want you to do. Here's what I want you to do. If this is f of x, I want you to find f of 4 for me real quick. Plug in 4 for x and tell me what you get. The whole problem. Yeah. Do it real quick. Clearly I didn't focus on this very much in Algebra 2 at all because y'all don't see where I'm going with this. You should get 0. So this is the remainder theorem, and this is what it does. It says if you plug in any number, right, when you plug that number into any f of x, what you get is the remainder. So another way you could find that is by dividing synthetically. In other words, if I wanted to know what is f of 5, well then what I could do is I could just say, I could do this, and it's a lot easier than actually plugging 5 in. 25 minus 9 would be 16. What's 16 times 5? 80. Yeah, so that's what this says. This says that it'll be the remainder when you divide by x minus that number is going to be what you get if you plug it in. It gives you the same value. This is f of 5. 80 minus 44 is 36. 5 times 16? Yeah. Oh, I did. Thank you, Corey. Slade. 21. 61. I'm sorry. I was only slightly distracted. Yes, so that it's kind of what I wrote down here. The remainder is what you get when you plug k into. Okay, if I the remainder when you divide by x minus k. The remainder when you divide by x minus k is the same thing as if you do f of k. Okay, that will give you the same thing, right, Charlie? When I divide by x minus k, it's the same thing as doing what? No. F of k, the remainder is. So if I asked you, what? I know. He did. All right, Charlie, this one's for you. Yeah. Without plugging in, Charlie, what is f of 1? And then tell me what is the remainder What's that? 11 is the remainder. How'd you get that so quick, Corey? Without plugging in. You do synthetic division? Oh. Thank you. I definitely said same thing over here. Because this is the remainder theorem, and we're going to use it to do something else. Right now, I'm just illustrating how it works. No. Same sign for synthetic. I mean, same sign when you divide, opposite sign. So when you plug in like this, it's just the opposite sign from here. I got 11. Is that what you got when you plugged in? Y'all see where I'm going with this, though? This remainder is equal to what you get when you plug in. That is the remainder theorem. If I plug in what I divided by, I'll get the remainder if I were to divide it all out. What does it make sense? Which part doesn't make sense? Okay, look at this one. We'll see. Evaluate f of 4 without using substitution. Hello, boys. No. Don't be sorry. I'm having a bad day, apparently. 5, 4, 3. Where? No. No, it shouldn't. That means x minus 4 is what I'm dividing by. Yes, no, maybe so. Where did that come from? The remainder. That's exactly right. The remainder. The remainder is what you get when you divide. All right, listen, guys. This is going to get, y'all got to pay attention if you want to get it. The remainder, when you divide by x minus a number, is the same thing you get if you plug that number into the equation for x. It always works like that. What? Well, sometimes you will. Sometimes that's what you'll need to do. Sometimes if it just asks you, if I said, Charlie, what's the remainder when I do... Yes. I did. What? No, I didn't, dude.
I'm not ready to make the opposite.
We did it both ways. Every single time. If it's k equals some number, it's the factor is x minus k, so you just put it in there. So if it's x minus 4, the opposite sign goes outside the synthetic.
Oh, I didn't see that.
So if you divide f of x by x plus 7, what remainder would you get? Now this time without dividing it, what would you do? Plug in -7. So f of -7 is the remainder when I divide by x plus 7. Yes. Yes. Do you understand what we're doing? He had a different outfit. Yes. But if you're just giving k, then it's the same sign. Because it's minus k. Right. Other questions about remainder theorem? Let's see if you can apply it. Listen carefully. The number of tickets sold during the Oakdale High School football season can be modeled by the equation. Calculus was telling me yesterday that they hate calculus that has so many word problems but when you dig down in them, they're all asking for the exact same thing, just a different way. The number of tickets sold during the Oakdale High School football season can be modeled by the equation where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. So you're just plugging in 7. So if I use remainder theorem instead of just plugging in 7, what can I do? Right. Yes. We're not there yet, but we will be there. Right. Yes. That's why we're 4 on the floor, Slade.
You are the man. I'm thinking doing them like back to back. Oh. Oh my God.
229. So how many tickets were sold? 229. All right, let's do factor theorem. Do y'all need a break? No, y'all don't need a break in between. We need to push through. Yeah.
What is she doing here? She left your.
All right. Who?
Lady.
Polynomial. This is factor theorem, by the way, and you already know it. But if I gave you a polynomial, like let's say f of x equals x cubed minus 31x plus 30, and I gave you x plus 1, x minus 5, and x plus 6, and I said which ones are factors, what could you do? Divide by one of them, right? Well, I would start with 1. You might get one of these answers whenever you divide. But dividing by a factor will give you a factor. Also, dividing by a factor with a remainder of 0 means it was a factor. What? Well, this is a cubic. It's not a quadratic. Yes. What? So is that a factor? Oh. So does it have a remainder? Is it a factor? It does have a remainder. I was wrong. Did you get hurt, by the way? Are you okay? Y'all are so mean to each other. That's a factor. How about this one? C. Yeah. It's just like calculus all over again. I'm just up here talking.